Alright, let's begin section 3.2, the slope of a line. Remember to print out the corresponding lecture notes so that you can follow along and work through the problems. Our objectives for section 3.2 are to find the slope of a line given 2 points on the line, and find the slope of a line given an equation of the line, graph a line given its slope and a point on the line, and use slopes to determine whether two lines are parallel, perpendicular, or neither. In this example, we want to find the slope of a line given 2 points on the line. One of the most important properties of a line is the rate at which it is increasing or decreasing. The slope is the ratio of the vertical change, or the rise, to the horizontal change, or the run. In this example, we're looking at 2 points going from P1 to P2. Notice that the point P1 is located above, and then as you go from point P to point Q, you're moving down. So we are going to be finding that rate of change. How fast is the line changing as you're going from P1 to P2? This can be expressed as a fraction, as rise over run. Now we have rise is -4. So that means from P1 to P2, you're moving in a direction, instead of positive going up, you're actually moving down. So we get a -4. The run represents the horizontal change. So from P1 to P2 in a horizontal direction, you're moving to the right, which we're looking at as a +12. So when we combine those to get our slope, we get the rise of -4 over the run of +12. Write that as a fraction and reduce it into lowest terms to get our slope as -1/3. So for every 1 unit or 1 foot you're going down, you're moving 3 feet to the right. So that's a total of 4 feet moving down and 12 feet to the right. So our slope is -1/3. We can also find the slope using a formula. To find the slope of a line given 2 points on the line, we use a slope formula. The slope of the line through those 2 points, we're using x1 and y1 as one of the points on the line. We're using x2 and y2 as a second point on the line. The way you calculate the slope with the formula is to calculate the rise, that's the vertical change, over the run, that's the horizontal change, that direction. So again, we can also write this as change in y over change in x. And as a formula, it's a difference between the y values in the numerator, y2 minus y1, that goes in the numerator, and x2 minus x1, that goes in the denominator. Now the requirement for finding the slope using these 2 points is that those two x values cannot be equal. Otherwise, you get a line that has an undefined slope. In this example, we're going to find the slope of the line containing the points -3, 1, and 3, 3. We can use the rise over the run, and we can also use the formula. Let's do it both ways. So let's begin using the formula, identifying the corresponding coordinates x1, y1, x2, and y2. Our first point given is -3, -1. So that means our x sub 1 is equal to -3, and the y sub 1 is equal to +1. The second point is the point 3, 3. That means your second x, or your x sub 2, is equal to 3, and your y sub 2 is equal to 3. Now we are simply going to plug those into the formula. For m, which is y2 minus y1, our y2 is 3, our y1 is 1, so 3 minus 1 goes in the numerator, In the denominator, we have our x2, which is 3, minus our x sub 1, which is a negative 3. Now be careful here when you're adding and subtracting integers with different signs. We want to do the entire numerator first. 3 minus 1 is 2, and 3 minus a negative 3 is equal to 6. Remember, minus a negative is a positive. So that's the same thing as 2 over 6. And 2 over 6 can be reduced to 1 over 3. Now that corresponds with the actual physical rise and run as you're going from the first point, negative 3, 1, to the second point, 3, 2. So let's look at the rise part. From our first point here, to get up to the same level as the second point, you move up 2 units. To find the run going from this point here in a horizontal direction, you'll see you would have to go 6 spaces to get to the second point. So our rise is 2, our run is 6, and that can be reduced to 1/3. That means for every 1 unit that you move up from this point, you move over 3 units. Move up 1 over 3, up 1 over 3, and so on. In this example, we want to find the slope of a line given the equation of the line. And in this case, our slope, we want to find the slope of the line 4x minus y equals negative 8. Now to use a slope formula, you need 2 points. So one way to find the slope of the line is by finding 2 points and then using those 2 points in the formula. Afterwards, we'll go over another way to find the slope of the line. So 2 points that are really pretty easy to find on a line would be the x and the y intercepts, which we did a few in the last section. So let's find the x-intercept. Remember, the x-intercept is found when y is equal to 0, and you write this equation replacing this y with 0 and simplify. You get the equation 4x minus 0 equals negative 8, and by dividing both sides by 4, you get x equals negative 2. And that corresponds to the first point when x is negative 2, y is equal to 0. Let's find the y-intercept. The way we find the y-intercept is by letting x equal 0. So if you take this equation and replace the x with 0, you get 4 times 0 is 0. 0 minus y is negative y equals negative 8. And by solving this for y, dividing both sides by negative 1, we get y equals positive 8. So that corresponds to another point, 0, comma 8. And what we can do is we can use the each point as each intercept as your point in your formula. So this is going to be our x sub 1, our y sub 1. This is going to be our x sub 2, comma, and y sub 2. We're going to plug those into the slope formula. So our y sub 2 is 8. 8 minus our y sub 1 of 0, all divided by our x sub 2 of 0 over our x sub 1 minus our x sub 1 of negative 2. Again, be careful with the signs here. Do the entire numerator. 8 minus 0 is 8, and 0 minus a negative 2, remember that minus a negative is the same thing as a positive. So we're going to get a positive 2. And 8 divided by 2 is simplified to 4, and you can also write this as 4 over 1, which corresponds to the rise over the run.